Now we are doing the analysis of selection sort here. The first step is we have to identify the input size. Our algorithm is directly depending on the number of elements in the array. As the number of elements in the array increases, the processing time is also increased. So the input size is here nothing but the number of elements, that is n. And the basic operation. In the second step, we have to identify the basic operation of the algorithm. Here, if you see these algorithms, this comparison will be done more number of times. It will take the number of times by this loop. So this comparison operation is the basic operation. It's a time consuming process. So this is the basic operation. That is nothing but a of j is less than a of minimum. If you see these algorithms, in the third step we have to identify whether there is any worst case, basic case is available. If you see these algorithms, there is no any best case and worst case, because we have to complete the loop without any intermediate termination. Means it has to complete all the loops to get the sorted array. So there is no any best case, there is no any worst case for this algorithm. Then we have to apply some summation formula. That means the total number of times the basic operation runs, we have to count here. That can be identified by this summation formula. The number of times the basic operation runs or executed is calculated using a formula called C of n is equal to, I am applying here two summation formula sigma. Okay, one is for I and one is for inner loop j. I starting from 0 to n minus 2 and j start from I plus 1 to n minus 1. And here I put 1 to indicate the basic operation. Okay, when you simplify or substitute this summation formula here, we've got this here, sigma I is equal to 0 to n minus 2. Inside this n minus 1 becomes here n minus 1 minus I plus 1 plus this 1. When you simplify it, you got this formula. Okay, this part minus this part plus this one. You got the formula here. When you solve this problem using mathematically, you found that 1 and 1 goes here. That is nothing but n minus 1 minus I. In the previous classes, you found that when you do such summations, its result is nothing but n minus 1 into n divided by 2. You already proved that the summation of this one is nothing but this. Okay, this indicates it's nothing but n square. This formula shows that it's nothing but n square. So our algorithm's efficiency is, selection sort algorithm efficiency is theta n square algorithm. And now if I want to compare how many times this basic operation is executing, that is swapping, how many times this swapping will be done, it's indicated by theta n. If you go to these algorithms, in one pass only one swapping will be done. It will find out it will scan all the elements and the minimum. Once minimum will be identified, it is exchanged with the first element. In one pass, it will do one swapping. So in n minus 1 pass, it will do n minus 1 swapping, approximately n. So the total number of swapping will be done is n. So it is called as theta n.